think Martin needs no introduction. We all know him. And we're very happy that he's giving a talk today on playing the long game, deep annotation of newest Assyrian letters and deeper linguistic questions about them. We're very happy to have him here. And
okay, so I think this is the first talk I've given in a setting like this. Might be the last here. But this is essentially talking about work I did last year at our university under Shai Gordon, as well as stuff I've sort of just continued independently this semester. So the talk will sort of be about proposals and work that doesn't really have a lot of returns or fulfillments yet, but it is indicating what can be done, what hopes to be done, and a little bit of a promise of some of that. So it's more about methodologies and setting up things and other things. So first, yes, we are living in the sort of the age of digital humanities, but actually if you look at a lot of the online cuneiform corpora, databases like CDLI, ORAC, Archibald, things that maybe if you're not in the field, you don't know exactly or understand the acronyms, but these are sort of, I would say, kind of becoming a little passé or not living up to sort of the potentials that NLP, machine learning, and other things, other sort of technologies you can use for the study of ancient languages. They tend to focus on word or token level metadata, that is lemmatization. There's usually not, say, sentence level syntactic analysis or even sort of lacking metadata like gazetteers, right? Place names, some of the databases have like that. And importantly, the search capabilities are somewhat limited. If you want to do linguistic searches, it's often sort of just by keyword, or you have to, yes, you can sort of use special syntax, but it tends to be also just kind of based on this, just searching through the raw text itself. And therefore, it also has implications for the I guess you could say, limits on pedagogy. Of course, these tools are a great boon to teaching and just making text available to scholars, but there's a limit. And to sort of show what I mean by that, we can look at an example from a parallel field of classics. So this is the ancient Greek and Latin dependency tree bank developed at Tufts University. It's based on the Perseus corpus, which was originally, yes, sort of just putting raw text first, Greek and Latin text online, but then with lemmatization. And it involved people making manual annotations, usually by grad students, where you can, within this corpus, if it's not clear, basically you can, here's your text from the Greek text, and it will have a parse basically of every single word in very complete detail. You can sort of filter out certain features, morphological features and such. You can search across, I believe, sort of across sentences or text for various features. And you can see how this would actually be very useful in language teaching. In addition, of course, to linguistic research itself. And that's sort of part of what I have in mind here. The diagram that you saw on the flyer, and which you see here, is basically a kind of, it still is kind of a master workflow pipeline. Pipeline is a metaphor used in digital humanities for basically kind of describing how you would process a whole bunch of texts or a data set to get certain outputs or to basically just arrive at certain results. The green stuff is stuff that is a pipeline that I've pretty well established. It's very streamlined, and it has to do basically with taking raw text files, still largely in what we call normalization. That is, of course, cuneiform is written on a tablet usually. It takes human interpreters to, say, first write that out in Roman letters transcription, but also sometimes we want to include phonological information, which means taking that transliteration and producing what we call normalization. So that's the presumed starting point there. And basically adding complete morphosyntactic analysis of that, right? That's the thing up in the top, and the details of that little bubbles I'll get through in a minute. But so that's sort of what I did in REL, and I'm still doing quite a lot of. But the additional two parts, that is the yellow and the red ones, involve something more grand, I guess, certainly much, I think, more work intensive, and I think unprecedented so far as cuneiform, and even a lot of sort of other ancient language studies. It involves, on the one hand, frame annotation, which I'll get to frames more in detail, but basically it's not just sort of annotating, say, what a single word means. It's really using, I think, the the best linguistic theory we have right now, cognitive linguistics, and saying, well, when humans produce language, what they do is they think of scenes in their heads, right? Or at least, or when they're speaking or when they're interpreting speech, they think of scenes, and scenes involve integral actions and actors. And in terms of, say, a sentence, right, a written sentence or something, it means that they kind of think of groups of words that come together. And that goes hand in hand with how they think of grammar, because the grammar will involve sort of these constructions that get paired with the frames. And that's a very high level of analysis that hasn't been done either in cuneiform. It's been done for lots of, or at least some modern languages, particularly in Berkeley with the FrameNet project. But I have in mind annotating corpora for these frames, basically. And then the red part is I briefly said it just a minute ago. It's sort of the grammatical or let's say the syntactic or morphosyntactic partner to that. That is, it's not just, say, parsing sentences in the way that we probably learn in school, or if you take let's say a generative linguistics class in college, that is sort of saying, well, here's the subject, here's the noun, or the predicate, or here's the adjective. It's really, again, sort of using what is probably a more realistic account of grammar, which says that humans build up sentences actually by these kinds of, like little constructions or modules, which aren't just about building trees. They're about, say, taking a scene, or they're saying, you start a letter with something like "Dear X," "Dear John" or something, and that's actual sort of a structure in your mind which tells you how to interpret everything. So it offers a lot more potential for analysis. And therefore, taking all these three branches and bringing them together on the thing on the right would be where we, add metadata, and we do all sorts of wonderful analysis. So let me now describe a little bit about how all this works. A lot of it is, this is not like, as I don't know why you're laughing, but this has to recognize that digital humanities, although it's hot, often doesn't have a lot of money. And even so, there are all these issues about getting teams together, getting people interested in working together. And what I found last year is really, I had to do everything on my own, essentially. And so we want, what I want to do, and what I think I've done in the work so far, is kind of present a methodology that allows an individual, say a scholar or random trained individual out in the world, to kind of start their own corpus and start annotating it in a way that actually leverages certain tools to let them actually just do a lot of things on their own, which is important. And that's what what bootstrapping is. It's essentially you kind of start building something, and then you use what you've partially built to help you build the future parts of that object, right? And it sort of snowballs. And that can be meant in different senses, in terms of annotating a corpus, annotating different versions of the corpus, like normalization or transliteration, or even sort of going from core texts to more peripheral ones. Like all of those things I'll go through. Now, there's a lot of parts in this little diagram. It represents basically the kind of specific steps that I went through to annotate corpora on the database ORAC, which some of you may be familiar with. But what it essentially is a whole bunch of, it's a meta project where individuals can work on their own particular projects along certain standards, and essentially place text put text online in a standard format. Usually, hopefully not everything, but say most of it involves what we call lemmatization. That is, you go through word by word, of course, you provide a phonological representation, you tell the part of speech, you can put it in an index and such so that people can search it, provide certain metadata and a translation and certain other metadata that makes a nice database. It's meant to take this kind of information and harvest the metadata and use a certain tool for annotating that's called inception. And it's very intuitive. An individual could learn how to use it quite quickly, and essentially start annotating sentences by literally sort of like drawing a little arrow from the verb to the subject, the verb to the noun, typing in, say, well, this verb is like third person singular and such. And the circle here is meant to represent the bootstrap process, where, say, well, it uses a language model. That is, I don't think the next slide, is that what the next slide is? Well, let me show you on this slide for a minute, right? It uses a language model, which is to say an automatic parser in this case, whereby, say, you would start by annotating a small number of texts by hand, and then you train the model on that, right? It's a neural model, which just means it's, using an optimization algorithm to give you the right answers based on some, set of examples it's learned from. And then you use that to essentially provide imperfect parses of new texts. So sorry, let me go back again to the circle, right? That's what this thing here represents, right? You start with, you hand annotate, provide what we call gold standard for a small set of texts, train the model, apply that to another batch of text, which is imperfect, but has done some of the work. And then you'll go check that work, right? Either you have to correct some things or you just have to complete it. And you could tell that'd be like 10% faster or 20% faster. And then you combine that with the original set and you train the model again. And as you do it, of course, you can, the model gets more accurate and you can start, sort of annotating by hand bigger batches of texts. And, that's essentially what I've been doing since. Again, this also leverages things from the ORAC database. But let me go back to the slide here about the model itself, right? This is talking about how the kind of, you've heard about machine learning or NLP, right? This sort of is meant to describe the various components that go into this model, which uses a set of Python code called Spacey. That's a package that is very popular amongst sort of, it's like older packages tend to be kind of either more academic or harder to use in general. Spacey is meant to be much more usable just off the shelf, but I found actually that taking these tools that are usually presented, say, if you want to parse a huge phone book in English, say, right, or do very specific things, for like big modern language corpora, just take all that stuff. Learning how to do basic things for a new language like Akkadian actually is a very steep incline. And I think it is actually a meaningful accomplishment that I, struggled through that by myself. And then on the GitHub page with the documentation, it sort of explains that for other people. Because, there's all these little details, right, that always, they scare away the humanists. They make it such that, you just want to find an engineer or something. But, hopefully this has sort of obviated some of that. Let me just roughly say on this diagram, right, it shows you different components of the model which give you that do certain analytical tasks, right? Like the tokenizer, of course, that's the most basic task of taking a raw, text file, splitting it up into individual words, right? Usually you have to do that all the time. You want to apply the lematizer, which is to say, if you've got a form like, say in English, right, like works, the verb, right? You want to know that comes from the verb work. And here is crucially where the ORAC data comes in handy, because in the text that I'm drawing from, everything has been lemmatized. You don't have to train the lematizer, which is actually a highly non-trivial process. The other stuff about like the part of speech tagging, some of that also relies on the ORAC data, but the hard part, I guess, is the syntactic and the morphologizer, that is the morphological analyzer, and that's where the hard work of doing the hand annotation and doing the bootstrapping comes in. And I should say, right, this kind of software is such that you can customize components as much as you want, right? There's a lot of possibility for bringing in other people's tools. Like I did try to bring in this parser, or I guess it's a morphological analyzer by Alexei Sahala last year, and tried to bring it in. I found it actually didn't improve the accuracy too much, but there's really an ability to sort of combine different things into this, provided you know how to do that, right? Okay, just a brief note about how I sort of extract or make use of the ORAC metadata. So I should say, what is metadata? Well, it's, you've got your text, but obviously in any publication or in general, Scholar would like to know where does it come from, right? Maybe if it's a letter, who's the sender and the receiver, what type of script it is, what type, what genre it is and such. And in ORAC, that is stored in these accompanying files, labeled by JSON, which means it's technically called a dictionary, but it's just a very standard sort of format, which is very hard to read. But once you understand how to read it, you can write a script that will actually extract all sorts of useful information. And for the language training, you basically want roughly three types, or gathering data into three types of files. That is the lemmas for the normalization, and as well as the transliteration. So I'll explain why that in a minute. And then of course just getting the pos tags and such, like whether it's a noun and such, and I'll sort of show how that works. Now here you sort of see examples of transliteration and normalization. I'll come together in pairs. Okay, so in addition, I should say, I did sort of experiment with providing what we call augmented data, which is just artificial sentences, right? In the beginning, because the model seemed to be really bad in certain ways, and so I thought, okay, why don't I just sort of write some sentences? And that is, perfectly valid, I think, even philosophically, I think it's perfectly fine. The problem, though, is that the amount of time it took to kind of write the sentences and process them, kind of ended up being just as much or more than I could have spent by just annotating more real sentences. And so it seems like what this might be good for is if you've got a very specific type of error that the parser is always missing, and you really want to just correct that, you could probably target that specifically. But because this is meant to be general parser, even if we're sort of restricting ourselves to say letters, right? Because it's meant to handle all sorts of constructions and configurations, it ends up not being, I think, so efficient, at least for one person. So I'll just throw that in there. Okay, so what's great about this method I found, and what's, I guess, maybe it's not that surprising, but is not just bootstrapping in terms of using the model to, say, annotate a small batch of text and then using that to sort of do some of the work ahead of time, right, with the imperfect predictions. But roughly speaking, everything that I've done for the normalized texts can kind of just be import or transferred automatically to the transliterated texts. So you may know, or let me just sort of explain, right? Typically in journals, what you'll find if there's sort of a publication of a text, at least in print, right, is transliteration. Because transliteration is really sort of just the kind of the sweet spot, I guess, for scholars in terms of they want to know what a text says in romanization, but they don't need to know necessarily the phonological form in normalization. Well, you might sort of understand that in terms of training a model, it's harder, or it takes more work. That is, it's just harder for the machine to learn how to parse things if you're just working with the transliteration, right? Because it's not actually representing the phonological information explicitly. So I decided early on to start with the normalization, because there's a ton of that actually in ORAC itself, even though within sort of the field itself, it's more restricted. But because everything because ORAC or the ORAC projects start with transliteration, and then they presume you add in the normalization as an extra feature, basically all information for any text, you've got pairs, complete pairs of information in terms of normalization and transliteration. And the method, the way I do things, is such that, well, once you've sort of, you've applied the model to, say, a normalized text, it produces an output, what we call conlu format, right? It just sort of has rows. There's a text, and then each line represents a word or a token, and then it's got different fields going across that represent, say, the morphological parse or the part of speech and such. Basically, you can just, you produce all these files for the normalization, and then you just need to kind of substitute two columns, pretty much, right? The form itself and then the lemma, or I guess it's actually just, it would be just one column, right? It would be just the form right here. You swap out one column with the normal, with the transliteration. I know you can't exactly see it, but basically, you're just doing a kind of massive text processing operation by just substituting in the transliteration, and then that file should basically be valid for the transliteration as it is for the normalization. There's actually a significant, albeit minor, kind of hiccup with getting the alignment right, but this is I think a major advantage, because again, by the end, probably we would want a model that actually works only on transliteration, but it's much faster to do with normalization. I haven't spoken about the performance of this parser yet. So in the beginning, that is, way back last year, I only annotated or aimed to annotate two sets of collections of letters from the what's called the SAA project, the State Archives of Assyria, which is the letters, other documents from the Royal Archives of Nineveh and the associated capitals. So it's two volumes, moderately sized, but not huge. And I was also taking in a set of data from the kind of precursor to this project, I guess. Some of you may have, I don't know, maybe Nick, only maybe, there was Miko Luko, I think, was here a number of years ago explaining, kind of doing something similar in terms of annotating text for rural inscriptions. But getting all the data that I could find of the format I wanted, and then evaluating the performance. What you should note about these columns is basically the low performance of LAS here, right? Most of these other scores are sort of high. With this, these other things, lemma just means how well it lemmatizes. Theoretically, that should be perfect or near perfect because it's just coming in from the table data. These other things like morphology is parsing, of course. But importantly, the syntax, right? Telling you whether a certain token is, say, the subject of a verb or let's call it, let's say, subordinating conjunction or an adjective, attached to something else. That's represented by the LAS. The UAS just means, does the parser actually connect lines together without regards to the label? And that has to do with how it's trained. But the very low score here for the letters, that's pretty low. And I found, even to this day, that score never really seems to get better as I keep adding it, even though I think subjectively, I think it's pretty good evidence that it actually is getting better at parsing in general. Just observing 100, annotating 1,000 more letters. And this holds for both the normalized and the when we're adding in other data, and even say this benchmark, which is to say, you could take sort of this very general model, kind of like the supermodel, which we call a transformer, very general sort of trainable model, and you could apply it to my data, ask it to do the same things, and you find, well, you still get the same low score, which means, there's sort of like a theoretical, or in terms of the general machine learning, I think, this is sort of as high as you could get on that score. But the reason, right, it's not like this is, it's not terribly surprising when you think about how letters are different from other texts, because I don't know if you can see these letters or these numbers and such. The low score of the parsing from the letters, right, 31%, the accuracy, right, is much lower than, say, the royal inscription, 70% here. So that's how, Luco and the other team, that's the statistics they got. And that just has to do, of course, with the fact that in royal inscriptions, you get, albeit sometimes grammatically or syntactically complicated sentences, very long sentences. They're often very regular, right? And royal inscriptions tend to be kind of repetitive in general. So once you've trained a certain set, you can predict a lot of them down the line. Whereas letters, well, there's two things, right? One is they understandably reflect vernacular speech. They tend to be elliptical, rely a lot more on pragmatic inferences. All of those things are much harder for a machine parser to learn. And of course, they involve idioms and even things we don't necessarily understand yet. So I guess that's a positive thing, right? To sort of explain away this score. Okay, now the amount of work that I've done on this parsing business, this is about accurate, right? So I've concentrated mostly on these letters in the Royal Assyrian Archives. That's represented by the red numbers in this column here, right? So there's basically, by like 20 or a certain number of decades ago, scholars in Helsinki began producing publications of these letters and other texts from the Royal Archives, coming out every couple of years, and they have maybe one or two scholars working on them. It takes a couple of years, but you've got a bunch of different guys, right? And so 21 is the most recent. And initially they were in print, but they've all been put online, lemmatized, right? Very good corpus to work with. And basically the percentages here just show, how much of each of these volumes I did. And if you look at it, right, basically I think that there are 7 of the letter volumes that I've done so far, starting from last year down to today. And then there are a number of other side projects like literary text on Zoom and things that I was doing along the way. There are still basically 2.5 letter volumes left. This is quite a lot, actually. It's quite substantial because each letter volume has 200 or 300 letters, and well, I don't know. It's, compared to sort of standard big modern online corpora, you might expect at least 100,000 words or such. But anyway, it's a lot of boring work, I'd say, but if you're on the bus or it's you can do a lot of it, and I think it's meant to pay off in the future because there's just nothing like this, I think, for cuneiform in general, even with sort of the EBL and stuff. It's I think it's necessary work. Let me just show basically. So that's sort of the annotation. What answers can we get out of this, or what other things can you do with it? Well, this is actually another one of these, call it new strategies, I guess, or up and coming sort of analytical tools that you probably see people doing, which is essentially, well, you want to convert the data into a format that you can use these very general kind of call them associative or graph-like search techniques. That is using linked open data. So if the original data was in a file that kind of encodes, let's say, syntactic parses where you've got one line, each line sort of says, well, the noun, this noun, is like the subject of another verb. You want to retain that information, but express it essentially in what we call triples. That is kind of these very general format, which allows you to kind of say, well, a certain word is saying in a given sentence, and then it's connected to another word, and I won't sort of explain exactly what I mean by these triples, but it's a very general search format that you could sort of use for any kind of database that's in that same format. And that's the beauty, right? These are kind of like massive, it's a database that is of such general but compatible format that you could search this database and then another database that's in the triple format, for like place names or other languages, right? You don't have to have database compatibility and all these things that have sort of segregated database searches before. Once you convert that to this data format, you can now basically do highly complex searches that don't require building in this huge sort of like apparatus of search window and then the syntax like and word A and word B. You just kind of use things that have been used in computer science for a little while, namely, in this case we would call it a sparkle query. That is a sort of a language, or it is a language, right, for specifying going through all these triples to get sort of, in this case, say searching for certain syntactic or morphological information of words, and I'll show you which one here, right? So this is actually some stuff that has yielded some publications. So an example here. So probably if you work in Semitics or if you're working with Akkadian, you observe this, and you may have, there's some discussion in the literature about it, but you read, say, the later Akkadian of the first millennium, and you notice, well, the prepositions often, they change, right? That is, before in, say, the second millennium, the basic prepositions are, say, in and ana, roughly in or to, but by the time of the first millennium, they seem to become compound prepositions, right? Like inamochi or inapani, right? So like to the face or in the skull or such. And, I was interested in looking at, well, can we find any sort of patterns, or just doing a sort of analysis of what I would call the body part constructions, that is, these compound prepositions that involve a body part, right? Like, again, in the face or in the mouth, right? In the ear, in the hand, stuff like that. And this is an example in Pan Shari Ilak, right? He went before the king, or he went to the king, he goes to the king, right? So you can easily, take this idea and encode it as a search algorithm. And because all the data, or because on the one hand, you've got a large set of gold standard annotations, that is, you've got all these volumes with the big bars here. Not only do you have that, but you can apply the model to lots of other texts, right? Even though you're not going to check them. And it works because even though the sort of the analysis score, the parsing score is quite low, when you look at why, it's often because sort of more complicated structures, like you've got an embedded question, right? And you need to connect it to the main clause, or you've got some sort of relative clause that it's hard to analyze. If you're just interested in finding structures like this, right? Like Inapani, the algorithm actually does quite good. And so you can actually search a lot more than the stuff than the gold standard annotations. And you get generally reliable results, right? And when you combine that with the metadata, like a certain letter was written at a certain time or from a certain receiver, such you might find something, which I think I did, right? This is just an example of the Sparkle query. It's I won't exactly explain what it means, but you could really sort of you could really ask quite a lot of questions, as long as the metadata is there. You can grab a lot of stuff. It's not sort of, you're not limited by the search tool that you designed in the first place. It's very open-ended. So I guess I should say, on the one hand, there's all these fancy tools, but the later part of the analysis is just kind of low key. That is, So I gathered basically all the examples of these BPCs. I made a table, and you can do that. Well, some of it is automatic, but you have to do a lot of other table manipulations. And along with the metadata and a link to the text, so you can go in and check it, because you unfortunately haven't found a way to provide the sentence or the clause around the construction just in the table, unfortunately. So you do that, and at least I found, I think, there seems to be, I guess, a dialectical variation in how certain of these compound prepositions work. So what you have basically are pairs of these constructions where the inamochi, the preposition with ina, is used by, say, the Neo-Assyrian dialect. So the letters, even though they're coming from the Assyrian Royal Assyrian archives, a lot of the letters are written in what we call the Neo-Babylonian dialect or script. And they seem to be a variation between the inas going with the Neo-Babylonian and the anas going with the inas going with the Neo-Assyrian, and the anas going with the Neo-Babylonian, where the verbs involve directed motion. And it recently occurred to me that maybe actually that's not so interesting or profound, because it could be that sort of the object, like if you're going down into the town, or that actually might be some of what's going on, because I'll get to why I think that might be in a minute. But so I haven't found out the reason for it. It might not actually be that surprising, but it's quite curious when you look at all the data, because the breakdown is quite surprising, I think, unless there's some massive skewing in the data, right? Because ideally, as a linguist, you would want to find minimal pairs, right? The Babylonian saying the exact same thing except as the Assyrian, and except you find one uses ana versus ina. That would be the best proof. We don't sometimes, a lot of this we don't have that. We have sort of approximate situations that show that dichotomy. But this is a kind of thing, I don't know, I haven't seen it talked about. And it, if you go into say Orak, you could search point-wise for anamuchi versus inamuchi. And you could sort of go by hand and looking through the examples, and that you would kind of get some of these same results, but you could see how that gets limited and frustrating if you want to expand the scope. Because this, right, you could just search for all types of the prepositions, right? Just plug this into the Sparkle query, and you do all this sorts of customization. Let me see, and this is a table, right? So far as I found it, right, the stuff on the left seems likely to show kind of dichotomy, because there's evidence working both ways, and then the stuff on the right could be because it's like you've got half of the pattern, but you don't have the other half to sort of cement the analysis. It's possible. So it's interesting, and that's what some of the publication is about. Yeah, okay. It is true, yes, there are a small percentage of counterexamples to this. They do come from the older part of the corpus, that is from Tiglath-Pileser III or Sargon II. That I think that is meaningful. Of course, you get a one-off example, some counterexample. It could be some mistake or something, right? But so this might be nothing, but it is suggestive, particularly when you begin looking at even older set of letters. And it's also, right, it can't be because of Babylonian scribal practices influencing Assyrian practices, because the direction of the change isn't actually right. So let me get on to something here, right? So what I just did, like this week, right, I kind of did the same thing as I did before, some of this table generating business, but actually just getting right to looking at, say, for these particular structures, these verbs and some of these prepositions, I actually did a search across not just all the letters in SAA, but actually a bunch of Middle Assyrian letters from one of the few projects on ORAC that deals with that, the text corpus of Middle Assyrian, right? It's a huge set of like 1,700 text letters, admin documents, as well as actually all the royal royal inscriptions of Assyria. And when you do that, actually I didn't find, I didn't search for everything again. I was only looking for specific things, but you find that there are a few anamuchis and analibis in places, not as much as you would think, because as I said, right, we know from Old Babylonian and older forms of Akkadian that the compound prepositions are not, they're not the standard, right? What you just find is ina something, ana something. But what we find is some of these these compounds creeping in, and they do seem to, there does seem to be some sort of maybe optional variation, like this example here, right? It's literally the same guy writing the same letter, and then one place he uses Anmuchi for a person, and then Ana for a place, right? And in fact, a lot of these things are written by the exact same guy, but or you've got things that seems like they should be the same because to bring to and to give to, right? But one has Muchi and one doesn't, right? So there seems to be, on the one hand, some new pattern creeping in. There's some maybe optional variation, and the older pattern, of course, is without the just the basic preposition. And it does, again, you could sort of begin proposing why some of these constructions seem to be preferred, like the compound preposition. It would seem to be preferred when, say, the object is a known pronominal referent, right? Because if you want to say Anna plus me, you would have to use sort of the oblique pronoun, and that doesn't seem to happen a lot for various reasons. So they bring Anna Mohita, or maybe there seems to be, I don't know, maybe a difference between if is the object a person versus a place, right? So you sort of get information like this. Again, you could sort of do some of this, very slowly with the old just search window of ORAC, but you could this sort of just exponentiates the scope and power. And I should also say another sort of benefit of having this data, right? Just doing the annotations is that you can generate basically, say, empirically based lexical information. Like there's no sort of like file, right? That just lists for all the Akkadian verbs we know, whether they're transitive or intransitive. I mean, of course, the dictionary will ultimately say that, like in the CAD, right? But it's print, it's not digitized and such. But roughly speaking, you can just create a variant of that information just by going through the conlu files I had and just searching and pulling out the right information. Like if just say if you got a verb, is there another noun that connects to it with the object relation, and then you get this table where for each verb you've got object, indirect object, oblique, and stuff like that, and that could serve as an approximation. Of course, it also depends on my interpretation of the grammar and such, but that's the kind of thing that could be useful for various purposes. Okay, let me skip now, or let me continue now to these other parts of the flow chart, because I mentioned, right, so all the stuff before was about the sort of the morphosyntax, the most basic kind of, let's say, straightforward or classic sort of task. And now going on to frames. The yellow part, right? It's yellow because it's experimental, right? It's not streamlined. I don't exactly know, what I want and not. But here's an example of a frame. So this comes from FrameNet, the project developed at Berkeley. Let's say you want to have the scene of attacking. Well, you've got, say, roles. You've got the assailant, you've got the victim, and the red and the blue would tell you, these example sentences, which examples of how you would annotate that, right? And you've got these other colors because some of them deal with temporal information, locative information, and importantly, the black item is, in this case, what we would call the target. That is, in this way of annotating things, there's a word that will evoke the frame in the mind of the reader or the speaker, whatever, and you want to gather all the information around it. So these colored things. That's how it's encoded in FrameNet. And here, yes, as always, what makes or breaks the idea in the beginning is whether there's a tool to annotate this stuff. And there is one. There's something that's developed by the Brazil, basically the Portuguese FrameNet project at the university in Brazil. They have a tool, again, not really easy to use if you're just coming off the street, and the tech support is not very great at all, but I think I have gotten it to work. And basically what it allows you to do is, in the case of Akkadian, right, you would feed it a text, and then you can start annotating it, provided that you have a database of frames here. So let me show you what that means. On the one hand, do I want to show this here? Let's see. Well, let's use this first, right? What you need to have on the first hand is your own database of frames for general language. And on the one hand, if you've got frames for English, you can sort of import some of them in for Akkadian, but depending on language specifics, you might need to modify or add new frames. And this is exactly what I do here, right? Some frames like, I don't know, eat might actually be very common, cross-linguistically, but other things like, say, in the letters, there's always the notion, of course, of just addressing someone, like, to the kings, servant so-and-so. And it seems like that should actually be, a specific frame for Akkadian, because that's how the text works. And that involves specifying the roles and also importantly, the lexical evocators. That is, you want to tell the frame which verbs or which nouns or whatever will trigger that frame. And that stuff you have to do by hand, roughly. That's where a lot of the work comes in. And when you do that, well, then you can go by, you upload a text. This is one that's should be broken by sentences. And then you just, let's go back. Oops. Right, you would kind of just highlight the nouns and tell which frame and such, and theoretically it's supposed to be kind of efficient, but I found that there's problems with it. So, that would be sort of the next step. Instead of just annotating letters for syntax, you would take those same texts and now plug in the frames and build the set of frames and decide things. And of course, when you do this, part of what philology is just working like a worm through a text or set of text, and you notice little details that you're never going to learn if you just say, oh yeah, I know, this is an administrative text, or I can read this in translation, right? It's sort of you learn for yourself, and there are little ideas that I get from stuff like Shitaru and Shiparu, and maybe it's not surprising to people, but it's discoveries happen often because you realize, you think about obvious things. So this is an example, right? Importantly, though, this annotator does not, although it seems to have certain, like the menu items, and some of it is built in for construction annotation, it doesn't actually allow that, which is kind of a shame, because you would like to have all these annotation tools or tasks built into one annotator, and it doesn't allow that. So we'll have to get to the construction annotation in a minute. But as far as frames work, this seems to be the best that we have. And of course, you can convert this to linked open data, right? To do the same kind of searches that I did with the, with the Anamuchi and the Inamuchi stuff, although that has yet to be, I just don't have enough data and any reason to kind of search through that. But you could begin to see, right? If you convert everything to linked open data, you could begin to say, okay, I've got this, like a set of triples about frames and the lexical evocators, and then I've got a set of triples about syntax. I could sort of search through both of them at the same time. The last thing is now what I said, the construction. And although it is labeled here red or purple, which means I haven't started it. I actually have started it, and so I can say some things about it. Basically, like I said, the FrameNet annotator proposes, but it doesn't seem to have functionality built in for it. And the guy said, it's going to be forever until they put it in, and it would be complicated to learn how to do it oneself. And there are even, I would say, fewer kind of software implementations of construction grammar, or they're outdated. Like Berkeley has one, so the only one that I sort of found is one based on what's called fluid construction grammar. It has kind of like a sandbox, an editor that lets you play around with things. And I want to just show you sort of what can be done with it. So, when I say construction grammar, in particular, this thing called fluids construction grammar, let's just say construction grammar, what does that mean? Well, again, the units of analysis, or the ontology of the language module is just thousands and thousands of quote constructions, which are form meaning pairs, right? Like you say verb object, right? That's a construction, and it will tell you something like, doing an action to an object, but it could be something very generic or very abstract, like, like noun one, two, like, N1, TO, N2, which means this is the beginning of a letter where the first one is the sender and the second one is the receiver, right? So it's very arbitrary sort of notions of form and meaning. And the way you formalize this, right, the way that you would sort of tell a computer to analyze a sentence or produce one, I guess, in terms of sentences, is you use the analogy of something like from organic chemistry or biology, where your input string is something like an organic molecule, right, something in the cell, and then the cell, of course, or I don't know a lot about biology, but it seems to be that the cell will release proteins, and those proteins will sort of glom, if they're of the right configuration, they will glom onto the organic molecule and transform it. And as you keep adding the proteins, that input organic molecule becomes the output molecule that it wants, right? On the right, what?
I think amino acids to make more protein.
What?
It keeps adding amino acids to produce more protein.
Well, okay, you would be well, we'll talk about that later. Okay, but the thing on the right, this is a representation of how you would encode the construction, say, in this fluid construction grammar, and it's very sort of abstract, very formal. On the one hand, yes, it's even harder, like, the amount of technical support and instruction or manuals for this is not great. It's been very, very frustrating just to even get very basic things. But I can sort of see, if you understood how to do it, you could really use, there's very powerful notions of programming in, all sorts of arbitrary constructions that would, you could sort of just transparently apply them to the input stream. And the thing down below is sort of what you might see in a textbook and how that, how this information is represented. So this is just, again, showing you how the parser would work, right? Transforming it. So how would I bring in, or how am I bringing in, I guess, again, part of this older set of information and tools that I've used into this? Well, on the one hand, you, of course, the power of this is you can encode frames, right? Constructions can, they include form and meaning. So you can encode, if the construction involves a frame, well, theoretically, the frame net database specifies the roles, and so you can just sort of type them and code them into a particular construction. Like in this one is one that I've actually done called the Assyrian salutation, right? So in Assyrian letter, you usually say Anashari, that is to the king, my lord, your servant, so and so. There's no verb and such, but it's very, very specific in meaning. And you can tell that the meaning is there's a salutation between the greeted and the greeted, so this that would come mapped over from the database. And then you sort of tell it, well, there's the meaning of the ana and the syntax and stuff. So this part, right, would come from the conlu files, and then the annotated would come here. So the point is, again, you could map in mass stuff from the left to the right. It's just deciding how to do the mapping. Is that it? No. Here's the like one of the few examples I've gotten to work so far, right? This is again part of the fluid construction module. That software that I said, right? The developers have made it such that you can display the results on the web browser, in this very intuitive and kind of appealing way, right? And you can sort of see, right, if the beginning string was on the shari, the input is just basically some code that tells you the string and the order of the words, and then it will begin applying constructions, including a word. Like a word itself can be considered construction. It will sort of like I forgot what you said. You mean the one molecule, right? It will begin looking through the if you've got your organic input string, it'll look for that attachment site. The attachment site is literally just the string shari, right? But the meaning is stuff like it's genitive and it means king, and it tends to be a high social status person or something, right? You start building up the input, and then you apply ana, right? So you attach ana to the shari, right? And then you can keep doing that, So yes, even to do even something more complicated than that has led to some problems. But this is sort of an example of how the construction grammar analysis would work, and there's no reason to think why again just putting in frames and such would be straightforward as well. So I think that is it.